taking this lesson out of Classroom Mathematics. We are currently busy with chapter 15, Area and Perimeter, and today we are going to look at the formula for area. So just to define area is the area of a closed two-dimensional shape is the amount of surface that it covers. So an overview of this video, we're going to look at the formulas, then we're going to look at a few notes, and then we're going to do a few practical examples. We're going to start with a square. So the square has 4 equal sides, and the formula for a square, for the area of a square, is area is equal to side times side, or in short, we can say that the area is equal to side squared. Now to look at how we're going to go about doing that, if we have a square and the side is 25 meters, then we know our formula is area equals to side squared. So now, since I know the side is 25, I can just substitute in the value 25 and square it, and then just put that on the calculator. So I have 25 squared, and that gives me 625. So this is 625 units, is very important, and this is meters squared. So in area, we work with units squared. Then for a rectangle, the formula for a rectangle is simply length times breadth. We can also simplify it by writing it as follows, but I would advise you to just learn it off by heart as length times breadth. If we look at how we're going to go about working out the area for a rectangle, we know our formula is length times breadth. Always when you start with the sum, write out the formula. That's a good way to learn it off by heart. Each time you have to use it, write it down. Then we substitute in length, which is 11 times by 3. And this gives us 33 meters squared. Alright, now for a triangle. Now the formula for the area of a triangle, half base times perpendicular height. Very important that the base and the height is perpendicular to each other. If we have an acute triangle as follows, then the height normally looks like this, where it lies inside of the triangle. So this is if our base is C and our perpendicular height looks is over here from the vertex to the base. We can simplify the formula as follows. And then if it's a obtuse triangle, the height normally lies on the outside, and it would look something like this. Right, so for a few notes on the triangles, every triangle has 3 different bases and 3 different heights. So for example, if we have PQR and our base is QR, that makes our height from the vertex of P down to the base of QR, or we could have the base as PR, which would make then the perpendicular height Q, from the vertex of Q down to the base. And finally, if we have the base as PQ, then it would look as follows. Then perpendicular height for an obtuse triangle. So as we saw previously, if our base is QR, then our perpendicular height, because the height has to be perpendicular to the base, will be the dotted line from the vertex of P. Then right angle triangles. With a right angle triangle, one of the 2 sides, one forms your base and the other one your height, because they are perpendicular to each other. So that's how you normally calculate the area for a triangle that is right angled. In the rare cases, we can calculate it as follows. Then it just looks similar to the other normal triangles. So for example, 1C, we have a right angle triangle. So if we need to determine what's going to be our base, what's going to be our height, our base, let's make our base BC. Our height needs to be a perpendicular to the base, so that's going to be AB. We don't know what AB is yet, but because it's a right angle triangle, we can use Pythagoras. So AB squared is equal to AC squared minus BC squared. By this time, you should be quite familiar with it. So then Pythagoras is what we used. Now just substituting in our values. So AC is 50 squared minus 40 squared, and then this gives us, oh yes, and then the square root sorry, AB is the, or AB squared, so AB is the square root of 50 squared minus 40 squared, and this then gives us the square root of 50 squared minus 40 squared, and that's equal to 30 meters. Alright, so now that we know this is 30, we can find the area. So our formula for area of a triangle, half times base times by perpendicular height. So substituting in our values, times by base is 40 and my perpendicular height is 30. And then I'm going to put that onto the calculator. 0,5, I just use 0,5 for half, that's just easier for me. Times by 40 times by 30 gives us 600. And it's going to be 600 meters squared. Then a circle. Now with a circle we have a radius and a diameter. The radius is the distance from the center of the circle to the circumference. The diameter is the distance from one point of the diameter, from one point of the circumference to the other point going through the center of the circle. And the formula for the area of a circle is pi r squared. So know this off by heart. And then also remember that the diameter is 2 times the radius. Now we're given the following circle and we're given that the diameter is 14 centimeters. If we need to find the area, we need to find the radius first, and we just saw that the radius is half of the diameter, which makes that 7 centimeters. So for the area of a circle, which is pi r squared, then the radius is 7, so substituting in 7 squared, this would give us 49, but let's just type that in as is. We have pi times by 7 squared. So this gives us 49 pi. And then if we need to round it off, which we normally do in our questions, if they state round off to 2 decimal places, for example, just press SD, and then we get 153,94. That's if we round it off to 2 decimal places. So 153,94, and we are working with centimeters squared. Alright, so that was the basic formulas for area. Let's just look at a few additional notes. Now, first of all, in calculations, all dimensions must be expressed in the same units. And basically what this means is you can get a figure and the given values for the different lengths might be given in different units. Always watch out for that. And what you need to do then is just to first convert the units to the same units. Then area is expressed in square units. So we saw with our final answers in the previous examples that we have to state our units when we finished is in millimeters squared, centimeters squared, meters squared, or kilometers squared. Now, if we need to do some conversions, but if we have, let's say we need to convert an area. Normally we convert lengths, like we know 1 kilometer is equal to 1,000 meters. But now let's say we need to convert 1 kilometer squared to meters squared. Now this is just steps to do it not direct. Like you can learn these conversions off by heart, or if you don't know them, you can break these up. So let's start with this one. We have 1 kilometer squared is equal to, then we break it up into 1 kilometer times by 1 kilometer. But we do know the conversion for a kilometer, that's 1,000 meters. So we convert each of these independently. That becomes 1,000 meters, 1,000 meters, and then we just multiply them together again. So that would give us that 1 kilometer squared is equal to 1 million meters squared. Similarly, if I, for example, have 1 centimeter squared and I have to convert it to millimeters squared, I first break it up into 1 centimeter times a centimeter, and then convert the individual lengths, and then times the lengths together again to get 100 millimeters squared. Now, calculations involving circles usually include the irrational number pi, and typical rational approximations for pi are 3,14 and 22/7. So those are the values that you used in grade 8. In grade 9, we're going to mostly use pi unless they explicitly state that you have to use for your value of pi 3,14 or 22/7. But because pi is your most accurate value, we use pi from now on. So use the pi button on your calculator for calculations, and do not round off until you get the final answer. So that was the notes. So now let's look at a few examples. For example 1, the outer perimeter of the square tile below is 32 centimeters. What is the area of the tile? Alright, so now what is given? We're given that the perimeter is 32 centimeters. What do we know about perimeter? We know the perimeter, if this is x, then we know what is the formula for perimeter. Perimeter is equal to 4 times x, right? Remember, the perimeter is going around the shape. So if we're given that the perimeter is 32 centimeters, I can substitute in the value for the perimeter as 32 equals to 4x. Then I can calculate x. I can divide both sides by 4 to get x on its own. So x will then be equal to 8. And we are working with centimeters, 8 centimeters. Right. Now that I know that x is 8 centimeters, I can very easily work out the area, because I know the formula for area is side squared, and my side is 8. So this would give me 8 squared, and this then gives me 64 centimeters squared. For example 2, determine the correct to 2 decimal places the area of the shape. Now in this case we've got a bit of a complex shape. Now if we have a shape like this, we always break it up into one of 3 different shapes and simplest shapes. So complex shapes can consist of either circles or triangles or rectangles. So we always try to break them up again into their different shapes. So if I just construct a line over here, then I can see if I name my shapes, A will be a rectangle, B will be a triangle, and C is a semicircle or circle. Now I know how to calculate the individual shapes of these. That's quite easy. So we calculate each shape on its own, the area of each shape, and then we simply add them together. Now let's start with A. So we know a rectangle. What's the formula for the area? It's length times breadth. Now do we have the length? We don't have this length. And how can we get this length? If we look at this triangle, this is a right angle triangle, and we know with hypotenuse we can get this, with Pythagoras we can get this hypotenuse side. So let's first do that, and let's call this x. So x squared is equal to 8 squared plus 6 squared. So that is Pythagoras. Then x is equal to the square root of 8 squared plus 6 squared. And that will then be equal to 8 squared plus 6 squared. So that's equal to 10 centimeters. Alright, so this is 10 centimeters. Now this will be easy to find the area for shape A, because that's just length times breadth. And the length times breadth is 4 times 10, which gives us 40 centimeters squared. Alright, now for the area of shape B, that is what? A triangle. So half times base times perpendicular height. Now what is my base? What is my perpendicular height? These two sides are perpendicular to each other. So my base I will make as the 6 centimeters. So this is going to be half times 6 times my perpendicular height, which is 8. And this gives me 0,5 times 6 times 8. So this gives me 24 centimeters squared. Alright, finally the area for shape C, figure C, which is a semicircle. Now we need the radius. So if we have a rectangle over here, we know the opposite sides are equal, so this must be 4. That means this circle has a diameter of 4. But what is the radius? If the diameter is 4, the radius is 2. So, and also note that this circle is half a circle. So how are we going to find the area of half a circle? We simply say half times the area of a circle, which is pi r squared. Alright, so substituting in our values, we have pi, our radius is 2, and then squared, and then calculating that, this is 0.5 times pi times pi 2 squared, or just 4. So this gives me 2 pi. Okay, now finally I can, and this is in centimeters squared, so finally I can now get my total area as the area of A plus the area of B plus the area of C, and this is then 40 plus 24 plus 2 pi. So we have 40 plus 24 plus 2 pi, and the answer is 70, so this says to 2 decimal places, so 70,28. 70,28 centimeters squared. Then finally, for example 3, calculate correct to 1 decimal place the area of the figure shown, which consists of an equilateral triangle placed on top of a semicircle. Now, important is that it's an equilateral triangle, because that tells us that this triangle is all sides are equal, which means all sides equal 6. Okay, so now we need to find the area. First of all, this is already broken up into a triangle and a semicircle. So let's start with the triangle. If we want to find the area of the triangle, we need a perpendicular height. So we can construct this line over here as our height. Then how are we going to find this height? Now, if we know that this base over here is 6. Now, the perpendicular height divides the base if it is for an isosceles triangle. So that means that if this is the whole base is 6, then this part over here will be 3. Now the reason I want that, for 2 reasons, that's going to be the radius of the circle, but also this triangle forms a right angle triangle where we can use Pythagoras to find h. So h squared is equal to, now the long side, 6 squared minus the other short side, 3 squared. So that's Pythagoras. Then h is equal to the square root of 6 squared minus 3 squared. And that is equal to 6 squared minus 3 squared, 3 square root of 3. So we're just going to leave it in its simplest third form for now, until we've done, it's only at the very end that we're going to use decimals to round off. Alright, so now since this is our height, it's still just a distance, so this is still just going to be in centimeters. Now to find the area, let's call this shape A and this one B. So to find the area of the triangle, we have the formula for triangle, half times base times perpendicular height, and then we substitute in our values. So base is 6 times pi, my perpendicular height, which we found was 3 square root of 3. And then we type that into the calculator, 0.5 times 6 times 3 square root of 3, and this gives us 9 square root of 3. 9 square root of 3. Alright, and then we go on to the semicircle. So the area of the figure B, now because it's half a circle, we have to say half times the formula for a circle, half times pi r squared. So our radius we know is 3, so half times pi 3 squared, and then type that into the calculator. So 0.5 times pi times 3 squared gives us 9 over 2 pi. So 9 over 2 pi. And then finally, the total area is then the area of A plus the area of B, and this is going to be equal to 9 square root of 3 plus 9 over 2 pi, and that is equal to 9 square root of 3, 9 square root of 3 plus 9 over 2 pi. So this gives us 29, to one decimal place is just 29,7. So 29,7, and this is in centimeters squared. That was the examples. So now you can go ahead and do exercise 15.1, all the calculations that has to do with area.